Hi everyone, today's Leetcode question called longest increasing subsequence. So in this question, we are given an integer array nouns, and we want to find the length of the longest strictly increasing subsequence. And by the way, subsequence is just a sequence that can be derived from an array using the correct order. So you see example 1 here, we have all these nums in this integer array, and the longest increasing subsequence happens when we pick these two, this 3, this 7, and this 101. So you see, these four numbers are strictly increasing, right? And the final thing we do is to return the length of this subsequence with 4. Example 2 here, we have this array, right? And you see, if we pick this 0, this 1, then this 2 and this 3 will get a longest increasing subsequence, and return its length also at 4. Okay, now check the examples. Let's think about how to solve this problem. So in this problem, I'm using the dynamic programming approach. And for dynamic programming approach, the most fundamental thing is to derive the transaction formula, right? So I have to write the transaction formula and this step. So let's say I and j refers to the index in the nums, and dpi refers the length of the longest increasing subsequence at I index. Here we want to use this formula, so dpi can either be the previous dpi, right? And we can choose to update the dpi. So how can we update? Well, we'll use dpj plus 1 to replace the previous dpi. Well, dpj plus 1. For this one, since numbers j is smaller than numbers I, want to gradually expand the subsequence. That's why we add 1 here. And after that, I want to recursively check the longest increasing subsequence at a j step. So I want to add dpj. Okay, let me use a graphical explanation with example to help you understand this formula. So let's say our numbers are equal to 1, 2, and 3, 2. And we also need to initialize the DP array, right? As we did in previous dynamic programming approaches. So DP array will have all value of 1s because if we choose single element, the length will be 1, right? And the length should be equal to the array. Okay, now finish the initialization of the DP array. Next thing to do the calculation, right? And let's say we set the I pointer at this stage. So let me use a different color. Let's say the I pointer at this stage, these two. Then the J pointer can only be this one, right? Because it has be smaller than the I pointer in terms of indexation. If that the case, you see dpi, which is dp1, will equals dp1. So use maximum sign here. The maximum between dp1 and what? And dp0, right? Because J index 0 plus 1. And see dp1 here is 1, and dp0 is 1. So maximum between 1 and 1 plus 1, which will give us 2, right? So now we replace this one with 2, right? 2 here. Okay. And to this step, we cannot move the j pointer further, so I have to instead move the I pointer. So clear this out and move the I pointer to here. And the j pointer should be initialized from the first element, so j pointer is here. So just cross this out and redo the calculation. Okay, and now we are moving to dp2, right? So I add dp2 here. And dp2 is the maximum between the previous dp2 and dp0 plus 1, because here j is an index 0. And we plug all these values. The dp2 is 1, and the dp0 is 1, right? And this is plus 1, so this one give us 2. And we update this one to 2. And after that, we have to keep moving the j pointer, because j still has some place to go around I. Move the j to here and change this to 1. Okay, so cross this out. And you see dp1 previously we had set to 2, right? So dp1 is 2, and 2 plus 1 will give 3, and max 21 3 is 3. So now dp2 is updated from 2 to 3, right? So this one is 3. Okay, now finish all the possibilities at I equals indexation of 2. Let's move I to the final position. So I here, and j again started here. Let's close this out. And now we are running dp3, right? You see dp3 maps into dp3 and dp0 plus 1 because j here our initialization of 0. So this one gives us the maximum between 1 and 1 plus 1. So it will be 2, right? We'll change this one to 2. And then want to move the j pointer to the next position. So first, just call this out. This out, okay. And you see that if we're moving the j pointer to 2, what will happen? The j pointer at this position. Then find this 2 is equal to this 2, right? So this means it does not satisfy the strictly increasing requirement. So I have to skip this value and keep moving j to next position. And you see if we're moving j to this position, still we found, okay, this 3 is greater than this 2, right? So the increasing requirement is not satisfied. So we also skip this one. And now we finish all this. So just close this computation step out. The final thing we want to do is to return the maximum value in this DP, right? So we want to find the maximum value. And what's the maximum value in this DP array? We have 1, 2, 3, 2, right? So of course the maximum value should be 3. And we just return 3 as a result and we're done. Okay, now finish the graphical explanation. Let's start in the coding part. Okay, the first thing to initialize the DP array. So we have a length of 1 and sorry, the value of 1 and the length equal to the numbers array, right? And after that, we want to go through all elements in the array, then another pointer j to go through the I, right? If when numbers at j is smaller than numbers at I, this means it satisfies the strict increasing requirement. So we can keep updating using this function. So just copying this function now to here. Okay. And finally, we just return the maximum of the DP array on top. Okay, let's submit the code to see it works. Okay, you see the time compressing memory usage distribution not bad, right? And I think the code is very short and easy to understand. If you find this video helpful, please like this video and subscribe to my channel. Thank you for watching and see you next time.